Hi, today I'd like to take you through the basics of being able to read this electrical schematic that was provided by the SMC for the FMS 200 system. It's an actual electrical schematic of the power circuit for the body supply module. At first look, it may look a little bit daunting, but after a little bit of explanation, you'll see that it's not too hard to read. First of all, we've got three lines that go across the top here, and if we zoom in on those lines, I'll explain them to you. Of course, we have L1, we have N1, and we have PE. So L1, of course, stands for line 1, or the hot connection. N stands for neutral, or the neutral connection. And PE stands for physical earth. So the next connections that we see, everything is derived from those three wires up top. X1, X1, and X1 here. These are all just terminal connections. The next step that it leads to is an on-off selector switch. The next electrical schematic symbol that we see here is an emergency stop button, and then again it goes to X2 connections, which are just some terminal connections that are found on the system itself. So if we scroll down a little bit more, first thing we'll find is that these connections here are in series, so meaning either one of these two devices here leads to L1, which is our ungrounded conductor, which powers the PLC. And if we were to activate either one of those, then the power to the PLC would shut off. Next we have L2, which is our neutral connection to our PLC. And finally we have our grounded or earthen connection here on our PLC as well. So in order to power up the PLC, it takes an L1, an L2, and a ground or earth connection. So let's look at some of these other devices. As we see here, everything is all connected from the top. We come over here, this is our ground connection, and it's coming over here to a 120 volts AC / 24 volt DC. And this is actually a power supply that's going to be used somewhere else in the system. It brings in 120 volts AC and it outputs 24 volts DC. Now, what's important here are these triangular things here that have the letters 4 on them. This means that this power is going to be going to page 4 of our schematic. Same thing if we look at this device here, we can see again it has a L1 connection, it has a neutral connection, and it also has an earthing connection, and it too is a 120 volt AC power supply. So it converts to 24 volt DC, it's also capable of 60 watts, and this power is going to page 2 of our schematic setup here. And the last one we have on this page is actually a 120 volt AC to 24 volt DC power supply, and it's capable of 120 watts. So the main power supply coming from the top here, as we can see, comes down and it feeds into the PLC, and it also feeds these three other power supply modules. So moving on, we're going to come across our next page, which is our input page. If we see here, SLC 500, DC common, all of these are inputs, I:20, 21, 22, 23, 24, etc. And here is the actual descriptions of each one of those inputs. As we look at the start push button, this is the IEC symbol for a push button. Notice that it's normally closed. Sorry, normally open. Here we have our stop push button, which is wired normally closed, and those two are important because we'll need to understand the difference of how they're wired, either normally open or normally closed, as we begin our PLC programming. The next switch that we have here is an auto manual selector switch, and notice it has a 2-position switch. Next we have our reset push button, which is I:23, and this is also a normally open switch. Our next input here in the IEC symbol here is for the manipulator back. And we'll find out later that we're going to have to determine what manipulator back means, and we may want to name these inputs something that's more common to our knowledge and be able to recall them as we look at them in our program. But this is a proximity switch that's activated by a magnet. And our next symbol here is manipulator forward. Again, this is another proximity switch. I:26 is manipulator up. I:27 is manipulator down. And if we come across here, we got I:28, and this is a vacuum switch. So once the station has generated enough vacuum, the sensor would be tripped and would send an input to the PLC. Next we have verify forward. We have pusher forward on I:210. I:211 is feeder backwards, and I:212 is feeder forward. And last but not least is input connected to I:213. This is a 3-wire connection, and it still works off of the principle of induction or capacitance. I believe this is a capacitive style switch. So this is the actual input connection, and notice if we look at the top here, it is a 24-volt connection, and the power is coming from page 1. If we look over here, we can see that the power is also being outputted, and it's going to page 3. So if we look here, this is page 3, so our power would be coming from that particular page. And if we look down here on the bottom, here it is, coming from page 2. It's not outputting anywhere, so it ends right here. And these are our outputs. And our outputs start with O:30, with it being an alarm lamp. And this, of course, is the IEC symbol for an alarm. This is our manipulator forward, and this is a solenoid. And we can look at it and determine that it is a single solenoid valve, so it means it only has one coil on it. Next is O:32, manipulator backwards, and this again is a single solenoid valve. Each one of these, O:33, O:34, 35, 36, and 37, are all attached to solenoid valves. And the last one here, no material, is also an alarm indicator, and we can tell that by the IEC symbol here for a lamp. So these are our outputs, each one attached to a solenoid or a lamp. And this is our DeviceNet module, which we will get into DeviceNet in a later lesson. And again, just some more terminal connections. So for review, this is our electrical power schematic, and this shows us how everything is physically wired, how the main power would affect the rest of the station. So if we were to throw the on-off switch here, we would expect to lose all power to our PLC. Again, this was our inputs, which are located in slot 2, I:20, 21, 29, 213, 214, etc. Notice we do have 2 spares here on the end, so if we wanted to expand this, we could add a couple more inputs to this particular card. Same thing here with our outputs. Our outputs go through O:39, leaving us 310 through 315 as spares, so if we needed to expand and add additional output devices, we could do so in the future. So again, this is the basics of being able to read an electrical schematic. I hope it has made it easier for you, and we will be using these in the future as we continue our PLC programming.